Okay, so this mini lecture is going to be a quick summary about units, particularly those units we want to be thinking about as we prepare for the MCAT or really any introductory course in physics. We often will focus on very specific units. We want to make sure we understand where they come from. Now, units are what we really use to describe the physical quantities that we measure. And here in the United States, we're used to units like the foot, to describe length, the pound to describe weight, which is actually also a force, and seconds to describe time. These are the imperial system of units, the foot, the pound, seconds. And we don't really even use those outside of the United States, and often not in science, mostly not. So we want to introduce the idea of the metric system. So the metric system of units are what we are going to see as we move forward in our study of physics, as you move forward in your studying of this particular topic. So, what is the metric system? Now, we often will hear this also called as the MKS system, and that's a piece of the standard units that we use in physics. The M in the MKS system is for our length dimension, and we use the meter. So the M, forgot the R there, in that MKS system is the meter. The K is our mass dimension. And for mass, we use a standard unit of the kilogram. So that K represents the kilogram. And then the S is our time dimension. And we use the second for that time dimension. So when you hear the word MKS system, that's really referring to the dimensions of length, mass, and time, which cover almost all of the dimensions and the units that we deal with in an introductory physics course. But there are a few more standard units that I want to introduce you to. So the MKS system is part of what's known as the standard unit system, the Standard International. So these are used all over the world and is the basis units used in science. They describe different dimensions, 3 of which are here, and then a few more that I'm going to introduce you to. These are our base units. So we're going to differentiate what we call a base unit from what we are going to define as a derived unit. So the additional base units I want you to be aware of. We've done length, mass, and time. That's part of that MKS system. Current is another base unit you will see. Current uses the unit ampere. Now I want to be a little bit careful here about current. We call it a base unit, but current actually is derived. It is an ampere is actually a coulomb per second. So that's a derived unit using a base, the coulomb being the charge. So the base unit for charge is coulomb, but you will sometimes be informed or told or use current as sort of a base unit. Charge is truly our base unit though. So that's coulomb per second. But an ampere is sort of the basic unit that we talk about when we're dealing with current. The amount of a substance, the base unit for the amount of a substance, which you'll often get talked about in chemistry, is called the mole. So the base unit for the amount of a substance is the mole. The temperature base unit is the Kelvin. Now when we learn, or when you see in the video bank of videos, the video library, when we do things about temperature, we'll talk about degrees Celsius, we'll talk about degrees Fahrenheit. That base unit is the Kelvin. So that's a conversion to more common language in terms of the temperature of a substance, but the base important is Kelvin. And then the last one I want to tell you about is intensity. And I'm running out of room, so I'm going to go over here. And this really deals with light intensity, so luminance. And that is the candela. All right, so those are our base units that we're going to see throughout all of our study of physics. Now, each one of these units has an abbreviation. We've already talked about some of them. The abbreviation for the meter is the M. The abbreviation for kilograms is lowercase k, lowercase g. Time is the second. An ampere uses a capital A. A coulomb uses a capital C. A mole uses lowercase mol. A Kelvin uses a capital K, and a candela uses lowercase cd. And the upper and lower case matter, so we want to be attentive to the proper units and abbreviations for those units. All right, so these are our standards, these are our bases. Everything in physics, all of the other measurements we take are derived from these base units. So I want to talk a little bit about this idea of derived units. This is the idea that we are relating these units in a specific way to describe fundamental physical quantities. So what might some of those quantities be? Current was a great example of that. Current, which is the amount of electrical flow, and we have a unit of an ampere, which is really made up of the unit of a charge per time, so coulomb per time. What might be some other ones? Well, we like to talk about things like forces or energy in physics. Forces and energy have units that they describe, and they're made up of our fundamental units. A force has a unit in the metric system of a Newton. So a force has a unit of a Newton. And we use the capital letter N for that abbreviation. A Newton is derived from our base units. A Newton is the equivalent of a kilogram times meter per second squared. I use this 3-line equation to talk about the equivalence in terms of units. So we have our base units foundational in that unit that describes a physical quantity, the force. Another physical quantity example would be energy. Energy we describe as a joule. We use the capital letter J. A joule is made up of kilograms times meters squared per second squared. So fundamentally, energy is in joules, but is made of kilograms times meters squared per second squared. And so even though we have these physical quantities with units that represent those quantities, force and energy are examples, there are others that you'll come across, we want to remember that they are derived units made from the base units. And as you learn and continue to learn about these different physical quantities, you'll understand a little bit more about where those base units come from. It is in the relationships to those dimensions to these physical quantities. And the last thing I'll leave you with is sometimes we give different names to units to represent really large numbers or really small numbers. So we talk about nanometers. Well, nano is an order of magnitude of 10 to the negative ninth. So a nanometer would be 10 to the negative ninth meters. Now, that is still foundationally in the base unit of meters, but we'll use it more generally as its own unit, a nanometer, for example. So be a little aware that we might be doing that as we move through our study of physics, but as a base, we want to always remember we're using the metric system. You might hear that as the MKS system. It, however, includes more than just the dimensions of length, mass, and time. It includes a lot of other dimensions as well. Charge, luminance, temperature, for example. And the derived units will be our physical quantities that come from those base units. All right, good job.